So sometimes when atoms come together to share electrons, they can actually form more than one bond with one another. So this happens if they have multiple places where they can share electrons. So carbon, for example, can share 4. So if we have the Lewis dot structure of the valence electrons, there's 4 places that it can share, while oxygen has 2 places that it can share. So if we form single bonds here, you can see that this oxygen is still unhappy because this one is not shared. This carbon is unhappy because there's 2 places that are not shared. And this oxygen is not shared. So this molecule is not stable. These guys are not happy. This would be equivalent to our ionic compounds still having charges on them that are not going to be neutralized. You've got free electrons that are not paired up and forming our octet rule. So the same thing would happen if you have nitrogen coming together, and we know nitrogen is one of those diatomic molecules. It should exist as N2. If it only formed one covalent bond, both of the nitrogens would be very unhappy because they still have 2 more places where they can share electrons. So neither nitrogen in this case has reached the octet state that they would like to reach and have 8 electrons surrounding each atom. So the only way the atoms in carbon dioxide, CO2, and molecular nitrogen, or N2, can have octets is by sharing more than 2 electrons between the different atoms. So a single bond is a covalent bond formed by sharing 1 pair of electrons. So a pair, remember, is 2. So each atom is sharing 2 electrons when it forms a single bond. In a double bond, the covalent bond is formed by sharing 2 electron pairs, or 4 total electrons between the 2 atoms. And a triple bond is a covalent bond that's formed by sharing 3 electron pairs, or a total of 6 electrons between the 2 atoms. So our single bond is going to be represented by a single line, as we previously discussed. If they're sharing more than 1 pair of electrons, you would indicate that by adding a second line for a double bond and 3 lines for a triple bond. So for our carbon dioxide to be fulfilled, the oxygen is going to want to share 2 electrons, with the carbon sharing 2 electrons with it. So now we've got a total of 8 electrons around the oxygen. And if this carbon also shares 2 pairs with this oxygen, the carbon is now okay and has 8 electrons around it, and this other oxygen has 8 electrons around it. And so all of the atoms have reached their octet state. We could rewrite this with our line expressions, and so we've got 2 electron pairs being shared between the carbon and the oxygen, and between this oxygen and the carbon. You'll notice that the oxygen also has 2 lone pairs of electrons that came from its own valence shell at the beginning. And so these electrons still have to be represented in the molecule. And you'll notice that carbon is sharing all of its electrons with the oxygen. And so they're all represented, all 4 of the valence shell electrons in carbon are represented in the bonds that end up getting formed with the oxygens. Nitrogen, from our last example, is going to end up sharing 3 bonds with itself, or with another atom of nitrogen, to form a triple bond. And you can see that each nitrogen then has 1 lone pair of electrons that's left from its valence shell. So you can see it starts with 1 lone pair, and then it wants to share at 3 different positions. Oxygen starts with 2 lone pairs and wants to share at 2 extra positions. Carbon doesn't start with any lone pairs of electrons. All of the electrons are unpaired and ready to be shared to get to the octet state. So ethylene is another example of a compound that contains double bonds. It's a simple compound. It's used commercially actually to induce the ripening of fruit. And it has the chemical structure of C2H4. So it's got 2 atoms of carbon. They're double bonded together. And then it also has 4 atoms of hydrogen, 2 on each of the carbons. So the only way for the 2 carbon atoms to achieve their octet state is if they share two pairs of electrons in the form of a double bond. If we have acetylene, so this is the same acetylene gas that would be used in welding, this has the formula of C2H2, and you can see that this carbon compound has a triple bond that's shared between the carbons, and then it's bonded each carbon to a single hydrogen. So the one thing that you can note from this is carbon always has to have 4 bonds to be happy. So you can see it's got 1, 2, 3, 4 for each of these different carbons. So these are examples then of multiple covalent bonds.